Welcome class 12th. Today we will discuss the next process of metallurgy. This is refining or the purification of metals, and in this part we will discuss different methods for refining of metals. So let's start. Refining. The process of purifying the crude metal is called refining. When we purify our crude metal and which is extracted from the isolation of the concentrated ore, then that metal is purified. This process is known as refining. To obtain metal of high purity, several techniques are used and which depend upon the differences in properties of the metal and the impurity. वो जो प्रोसेस हम यूज करेंगे वो डिपेंड करेगी डिफरेंस प्रॉपर्टी मेटल की प्रॉपर्टी पे और impurity की प्रॉपर्टी के डिफरेंस पे. So these techniques are as follows. First is distillation, liquation, electrolytic refining, zone refining, vapor phase refining, and chromatographic methods. Now come to the first technique, distillation. This method is useful for low boiling metals. ये मेथड उन मेथड्स के लिए उन metals के लिए यूजफुल होगी जिनका boiling point low होता है. And in this method the impure metal is evaporated to obtain a pure metal as distillate. For example, like zinc and mercury. This can be seen in the image also. And here in this part, impure liquid, boiling liquid is present whose boiling point is very less. That metal should be present here. And as we have provided heat, so on the distillation process, as the condensation start, then we will collect our distillate or the metal as a distillate in this beaker here. So this is the distillation process. Next is liquation. This method is used for refining the metals having low melting points. For example, it is used for refining of tin, lead, bismuth, etc. Metals which have low melting points. And what happens in this process? The impure metal is placed on the sloping earth of the reversibility furnace and is gently heated in an inert atmosphere of carbon monoxide. Now the metal melts. Since we have already discussed that in this process we are using the metal which are of low melting point, so the metal will get melt and flow down, leaving behind the impurities. And the pure metal is collected at the bottom of the sloping earth in a receiver. So this can be seen in the image also. This is a sloping earth here. It is a sloping earth here, and the impure metal is poured from this side, and in the sloping earth, as we have provided the temperature here, the inert atmosphere, as it is heated in the inert atmosphere of carbon monoxide, then what will happen, क्योंकि हमारा जो metal है उसका melting point बहुत low है, तो metal हीट करेंगे तो मेटल क्या होगा, मेल्ट होके इस स्लोपिंग हर्ट से डाउनवर्ड साइड को मूव करेगा और वो कलेक्ट हो जाएगा प्योर फॉर्म में इस बीकर में. जो भी हमारा कंटेनर और द रिसीवर है बॉटम साइड में वहां कलेक्ट हो जाएगा. वहीं पे जो इम्प्योरिटीज होंगी वो इस स्लोपिंग हर्ट में ही रह जाएंगी. इम्प्योरिटीज लेफ्ट बिहाइंड बिकॉज दे हैव हाई मेल्टिंग पॉइंट एज कंपेयर टू द metal. So this is the liquation process which is used for low melting point metals. Now come to the next, electrolytic refining. This method is based upon the phenomena of electrolysis. And in this method, the impure metal is made to act as anode. Impure metal will be present at anode, and a strip of same metal in a pure form is used as cathode. So anode will act as an impure metal and the cathode will act as a pure metal. Now they are placed in a suitable electrolyte bath and electrolytic bath containing soluble salt of same metal. As we are doing electrolysis, so the electrolyte must be there, and these two electrodes, anode and cathode, will be placed in that suitable electrolyte. And on passing current, as we know that electrolysis is the process where the electrical energy is converted into chemical energy. This is the electrolysis process, as we have already discussed in electrochemistry chapter. So on passing current, metal ions from the electrolyte are deposited at the cathode in the form of pure metal, while the equivalent amount of metal dissolve from the anode into the electrolyte in the form of metal ions. Now the impurities fall down from the anode as the anode mud, because anode is containing a impure metal, so impurities will fall down in the form of anode mud. So at cathode the reaction is metal ion will gain electron and will convert it into metal, and at anode metal will lose electrons and will get converted into metal ion. This process, example for electrolytic refining, copper is refined using electrolytic method. We have already discussed the refining of copper in our electrochemistry chapter, and here we are again explaining it. Now what happens in this method? Anode having impure copper and pure copper strips are taken as cathode. The electrolytic solution here is the solution of copper sulfate, acidified solution of copper sulfate. Now the net result of electrolysis is the transfer of copper from the anode to the cathode. Copper will transfer from anode to cathode, and at anode the reaction will be as copper losing 2 electron gives copper ion, and cathode gaining 2 electron it will form copper in the pure form, and the impurities settle down below the anode in the form of anode mud, as we have already discussed earlier. So this can be seen by the image. Since at anode this is the this is the impure electrode, impure copper is present at anode, and as we have as the supply of current is started, as the current is provided, then what will happen? The copper the copper ion will get in the solution and the release of electron will be there, and impurities will settle down under the anode इलेक्ट्रोड. इम्प्योरिटीज उस एनोड इलेक्ट्रोड के नीचे सेटल डाउन हो जाएंगी और उस इम्प्योरिटी को हम बोलते हैं एनोड मड. और यहाँ से जो कॉपर आयन एनोड से रिलीज हो रहे हैं, इलेक्ट्रॉन्स एंड कॉपर आयन जो एनोड से रिलीज हो रहे हैं, वही कॉपर आयन और इलेक्ट्रॉन कैथोड में जाके वो उसे कैथोड उसे गेन कर लेगा, और जब कैथोड उस कॉपर इलेक्ट्रॉन को गेन कर रहा है तो वो एक प्योर कॉपर के फॉर्म में कन्वर्ट हो रहा है. सो इस प्रोसेस में जो हमारा इम्प्योर कॉपर का जो इलेक्ट्रोड है वो उसका जो प्रोसेस है, जब प्रोसेस स्टार्ट होगा इलेक्ट्रॉन ट्रांसफर होंगे, तो जो इम्प्योर कॉपर की जो इलेक्ट्रोड है वो उसका साइज बहुत थिन होता जाता है, वेयर एज द साइज ऑफ दैट कैथोड इलेक्ट्रोड, जो कॉपर का जो प्योर इलेक्ट्रोड था कैथोड पे, उसका साइज थिक होता जाता है. सो दिस इज द प्रोसेस ऑफ इलेक्ट्रोलाइटिक रिफाइनिंग ऑफ कॉपर. Come to the next process, zone refining. This method is used for metals which are required in very high purity. And example for these methods, germanium, silicon, boron, gallium and indium like. It is based on the principle that impurities are more soluble in the melt than in solid state of metal. Now the process of zone refining. A circular mobile heater is fixed at one end of the rod of the impure metal. As the heater moves forward, the pure metal crystallizes out and melt, and the impurities passes on to the adjacent molten zone. This can be seen by the image. There is a circular mobile heater is present. This is a circular mobile heater present, and at the one end of the rod ऑफ द इम्प्योर मेटल, एंड उसी के एक एंड पे हम एक इम्प्योर मेटल की रॉड को रख देंगे. वो रॉड जर्मेनियम, सिलिकॉन, बोरॉन, गैलियम, इंडियम इस टाइप के मेटल्स की होगी. उस रॉड को हम रखेंगे इस हीटर के एक एंड पे और हम हीटर को धीरे धीरे मूव करवाएंगे फॉरवर्ड डायरेक्शन में. नाउ व्हाट विल हैपन? द प्योर मेटल गेट क्रिस्टलाइज आउट. जो प्योर मेटल होगा वो तो सॉलिडिफाइड हो जाएगा, बिकॉज वी हैव ऑलरेडी डिस्कस्ड अर्लियर दैट दिस मेथड इज बेस्ड ऑन द प्रिंसिपल ऑफ impurities are more soluble than the metal in their solid form. So जो metal होगा वो तो क्या होगा, solidified होता रहेगा heat के साथ, लेकिन impurities क्या होंगी, वो लिक्विफाई होंगी और इम्प्योरिटीज सॉल्युबल होंगी, और सॉल्युबल होने के बाद वो पास होके हमें एक दूसरे एडजेसेंट जोन, मोल्टेन जोन में मिल जाएंगी, मतलब इम्प्योरिटीज हमें मोल्टेन स्टेट में मिलेगी, और वहीं पे जो हमारा मेटल होगा वो क्रिस्टल फॉर्म में मिलेगा, सॉलिडिफाइड फॉर्म में मिलेगा. नाउ दिस प्रोसेस इज रिपीटेड सेवरल टाइम्स एंड द हीटर इज मूव्ड इन द सेम डायरेक्शन. इस प्रोसेस को बहुत बार रिपीट किया जाता है और हीटर को सेम डायरेक्शन में मूव करवाया जाता है. Now at one end the impurities get concentrated. एक एंड ऐसा होगा जहां पे सारी impurities इकट्ठी हो जाएंगी, क्योंकि impurities तो हीटर के साथ मूव करती हुई जा रही है आगे को, और एक एंड पे आके impurities इकट्ठी हो जाएंगी और उस एंड को हम कट कर लेते हैं. बाकी जितना हमारा प्योर मेटल था वो पूरा प्योर मेटल हमें क्रिस्टलाइज होके दूसरे एंड पे मिल जाएगा. Now come to the next, vapor phase refining. In this method, the metal is converted into its volatile compound, while the impurities are not affected. During the compound formation, the compound formed decomposes on heating to give pure metal. Metal volatile होगा but impurities volatile नहीं होंगी इस process में. So, thus the two requirements are there. The metal should form a volatile compound with a available reagent, and the volatile compound should be easily decomposable. This is the condition here. The volatile compound which is formed through the metal, that should be easily decomposable, so that the recovery of metal is easy. And example which illustrate this techniques are, one is Mond process for refining nickel, and the second one is Van Arkel method for refining zirconium or titanium like metals. Now let's start Mond process of refining nickel. What happened in this process? In this process, nickel is heated in a steam of carbon monoxide, forming a volatile complex, and the volatile complex is nickel tetracarbonyl. Since nickel combines with carbon monoxide, it forms a complex nickel tetrachloride NiCO4, and the carbonyl is subjected to higher temperatures so that it is decomposed, giving a pure metal nickel. So here this carbonyl is a volatile compound, and this complex, as we have already discussed, that the volatile complex should be decomposes. So this volatile compound further decomposes on giving the temperature, and it will give pure nickel and release of 4 of carbon monoxide. Similarly, come to the next, Van Arkel method for refining zirconium or titanium. So this method is useful for removing all the oxygen and nitrogen present in the form of impurity in the metals like zirconium and titanium. Now, the crude metal is heated in an evacuated vessel with iodine. Here, the metal is heated with iodine in Van Arkel method, and the metal iodide being more covalent and it gets vaporizes. मेटल कंबाइन होगा आयोडीन के साथ, और हीट कंबाइन होने के बाद एक कॉम्प्लेक्स फॉर्म करेगा आयोडीन के साथ, और वो कॉम्प्लेक्स एक वेपराइज फॉर्म में, और इजीली वो वेपराइज हो सकता है इस तरीके का कॉम्प्लेक्स. सो हियर एज जिरकोनियम कंबाइंस विद I2 twice of iodine, it gives ZrI4. A complex is formed here, and the metal iodide ZrI4 is decomposed on the tungsten filament. Temperature provide करेंगे electrically heated to about 1800 Kelvin. The pure metal is thus deposited on the filament. Now as temperature हम इसे provide करेंगे इस complex को, तो ये vaporize हो जाएगा complex, और हमें metal zirconium plus I2 के form में हमें reaction मिलेगी. So this is all about vapor phase refining. Next process is chromatographic methods. This method is based on the principle that different components of a mixture are differently adsorbed on an adsorbent. So chromatography separation is basically on the principle of adsorption. Principle works on the principle of adsorption. The mixture is put in a liquid or a gaseous medium, and that medium is known as mobile phase, which is moved through a porous medium adsorbent called stationary phase. And the different components are adsorbed at different level of the column. Then the adsorbed components are removed. जो कंपोनेंट्स रिमूव हो जाते हैं, जो एड्सॉर्ब कंपोनेंट, एड्सॉर्प्शन से जो एड्सॉर्ब हुए थे जो कंपोनेंट रिमूव होते हैं, उन्हें हम बोलते हैं इल्यूटेड कंपोनेंट्स। एंड बाय यूजिंग सुटेबल सॉल्वेंट, और जब हम जो सॉल्वेंट हम यूज करेंगे कंपाउंड्स को रिलीव करने के लिए, उनको क्रोमेटोग्राफिक मेथड्स में इल्यूएंट बोलते हैं। एंड दिस प्रोसेस ऑफ एक्सट्रैक्शन ऑफ एड्सॉर्ब कंपोनेंट इज कॉल्ड इल्यूशन। जो पार्टिकल्स एड्सॉर्ब हुए थे जिनको हम रिमूव करें, दे आर नोन एज इल्यूट। एंड जिस सुटेबल सॉल्वेंट से हमने उन्हें रिमूव किया था, दे आर नोन एज इल्यूएंट। एंड जो प्रोसेस होगा, डेट इज नोन एज इल्यूजन प्रोसेस। सो दिस कैन बी सीन here in the image. This is a column chromatography image in which based on the principle of adsorption, and in which one phase is mobile phase which will act as a medium, and the other phase which in which the adsorbent is present, that phase is known as stationary phase. So this is the chromatographic method for the purification of the metal. Now question and answer time. So question is, name the common element present in the anode mud in electrolytic refining of copper. Why are they so present? So what will be the answer for this? Let's see. The anode mud in the electrolytic refining of copper contains the impurities. Since mud is impurity, so that mud will be selenium, tellurium, antimony, silver, gold and platinum. These are present as an impurity, and they are less reactive and are not affected by the electrolytic solution. The electrolytic solution for copper sulfate is for copper refining, or for the copper electrode, is acidified copper sulfate, that is CuSO4 or H2SO4, and hence these impurities settle down under the anode as anode mud. Now you have some questions as home assignment, so do these questions. What is the role of iodine in the purification of zirconium? Explain zone refining. Describe the method for refining nickel. Name the method for refining the following metals, and the metals are given here. Give equation for the industrial extraction of zinc from calamine. So this is all about zone refining, and thank you. That's all for today. We will meet with some key points of the metallurgy chapter in our next video. Thank you. Keep watching.